Hello mathematicians, we're now going to have a look at gradients of intervals and lines, and this should be something you're very comfortable with. So we know that the gradient or the slope of a line is the same as, and as long as it's a straight line, is the same as the gradient of any interval on the line. And it's calculated by rise over run, and we know that it's really just a special application of Pythagoras in a sense, again. And the formula is y2 minus y1 over x2 minus x1. The thing about using the formula is that you just need to be consistent. Once you pick out one set of coordinates as the ones you're going to call y1 or x1, then you just have to do that consistently through there. If the line tends upwards to the right, then the gradient is positive. If it tends downward to the right, the gradient is negative, or something I'm sure you're very comfortable with. What you may not have seen before, it is in some aspects of the junior course, but whether you have or not, the angle that a line makes with the... just trying to read my own grammar here. The angle that a line with gradient m makes with the x-axis, so in other words the angle to the horizontal. So in the case of this line up here, it's that angle. In the case of this line, it's that angle. Then that angle is known as the angle of inclination, and clearly it's measured going anti-clockwise, and the value of the gradient equals the tan of that angle. Now if you have a horizontal line, then the angle that it makes with the gradient is 0 or 180. So that horizontal line has a gradient of 0, but the simplest way of thinking about it is that it has 0 rise over an infinite run. And a vertical line, such as x equals a, so a vertical line like that, has the gradient undefined because there is an infinite rise over 0 run, and we know we're not allowed to divide by 0, so that's why we have the undefined. Now I might just jump to the GeoGebra very quickly. So here we have 2 points on this particular straight line, just to show that the points, well, I'll do a calculation. So the gradient of the line is going to be the rise over the run, which in this case is, so I've picked to go into the formula this as my first value, so 4 minus minus 2 to give us 6, 6 minus minus 4 to give us 10, so the gradient works out to be positive as we'd expected, 6 over 10, 3 over 5, 0.6, doesn't matter too much how you express it. And the angle of inclination, this angle in here between the line and the x-axis, is close enough to 31 degrees. Now if I just change this point to another one on the line, so I think 1, 1 is on this line, hopefully we will see that nothing changes. I change that to 1 and that to 1. Then yes, so nothing changes. So this is just reinforcing the point that it doesn't matter which two lines you take, which 2 points you take on the line, the slope of the interval is the same as the slope of the line. Now our next points are way more important than the space they're given might have you believe. So the first point is that two lines are parallel if their gradients are the same. And of course when we stop and think about that, that makes absolute sense. This is not quite so obvious, and you probably haven't encountered this before. 3 points are collinear if the gradient of A to B equals the gradient of B to C. Now you might be thinking, well, I can have 3 points and the gradient of between two of them can be the same as the gradient between those two, and all that they are is parallel. But the thing is, you need the gradient from A to B to be the same as from B to C. So B has to be on both parts, and the only way we can do that is if the 3 points are on the same straight line and have the same gradient. Next point down here, two lines are perpendicular if the product of their gradients is -1. So that is this, or that m1 equals -1 on m2. The gradient of the perpendicular line is minus the reciprocal of the gradient of the other line. Doesn't matter which way you work with this, but if you have to do something about proving lines are perpendicular, you have to restate one or the other of these to justify your conclusion that two lines are perpendicular. So very quickly, I'll just do one of these. We want to find the gradient of the interval AB and then the gradient of a line perpendicular to it. So for me, again, I like to draw the picture here because I know whether I'm expecting a positive or a negative answer then, in case I do something silly with the algebra. So for AB, -5, -2 is going to be out here and down a little bit. And 3, 2 is going to be here and up a little bit. So I expect my answer to be positive. And then in any order at all, if I just say that the gradient is y2 minus y1 over x2 minus x1, I don't always have to write that formula. You might want to do it a couple of times to get your head around it. And for some reason, I often take the one on the right, but again, there's nothing important about that. So 3 minus -5 will give us 8. Over 2 minus -2 will give us 4. This line ends up with a positive gradient of 2. And the gradient of the line which is perpendicular to that is -1 over 2. Now, this next question depends a little bit on how much you did about trig. So using this formula that the gradient equals tan of alpha, where alpha will be this angle in here, find the angle of inclination. So for the first one, for example, we've got that 1 equals tan of alpha. Now that means that alpha equals the angle whose tan is 1. So we can use that function on the calculator. Make sure your calculator is set to degrees for the moment, and that should give us 45 degrees. Now if you learnt your trig ratios in junior school, then this one should be relatively straightforward. So the angle whose tan is 1 on root 3 is going to be 30 degrees. So, but you should set the problem up just like this. The angle whose tan is 4, you're going to have to use your calculator to work out. So alpha is the angle whose tan is 4. And this one here, minus root 3, then you might remember, so this is making you dig back a long way, you might remember that the quadrants in which ratios are positive, all of them in the first quadrant, and then in the second quadrant only sign is positive. So when we get -3, then that's really telling us that our line is a line with a negative gradient. So it's got, and then we need to evaluate that. So the angle whose tan ratio is root 3 will be 60 degrees, and we're talking in that case, so digging up all your old trig, 60 degrees here. The angle that we want is this one, which is 120 degrees. So this might just throw you a little bit, but you'll soon remember the stuff that you did in junior school on that. And we will definitely back it up later on when we do trigonometry. Now, lastly, with this question here, what we're going to see is that if we sketch these up, so A is at -1, 1, there's A, B is at 3, -1, so down here somewhere, C is at 5, 3, so out here and up there somewhere, and D is at 1, 5, so up there somewhere. We've got this quadrilateral, It's vaguely like that, very vaguely. So, show that the opposite sides are parallel, and hence that it's a parallelogram. Now, I'm not going to work through all of this because I'm pretty sure you can do it. But that means that if I take the gradient of AD, so it's the plan which is more important than the calculation. Take the gradient of AD and the gradient of CB. If they're the same, then those two lines are parallel. Gradient of AB and DC. If it's the same, they're parallel. And again, it doesn't matter what order we take these points in, we'll always get the same numbers. For what it's worth, even on my sketch, they're both positive, they're both negative. So anything with two pairs of parallel sides is a parallelogram. Show that AB is perpendicular to BC. So we're going to show that there's a right angle here. How do we do that? Well, remember, if we take the gradient of AB and we multiply that by the gradient of BC and we get -1 as our answer, therefore AB is perpendicular to BC. So that's the logic behind our plan. So if that's the case, if we have a parallelogram with one right angle in it, then that will make all the others a right angle, so it becomes a rectangle. And finally it says show that the length of AB equals the length of BC. So that's our distance formula there. So when we show that that length equals that length, the parallelogram with a right angle and with two adjacent sides the same length must be a square. Okay, we could now have a go at these questions out of 5B. Again, if the early ones are too easy, be selective. Make sure you go to the harder ones where you actually need to develop a plan.